Let's take a look at solving growth and decay equations or application problems. First thing we're going to start with is this equation, which should look familiar. And K is the rate. It's the general formula that we use when solving decay and growth problems. T is time. It could be given in years, hours, minutes. The problem will give you that. E is just a number. A naught, which is the A sub 0, is the initial amount that you have of whatever material you're talking about. And TA on the left-hand side is the amount after T times at this particular rate that they give you. Now, in this equation, any of these variables could be missing. We're going to go through a scenario for each of them so that you can see how the problem solving may change. We start with the time missing. So they want you to find the amount of years it takes at this rate, 0.26, which is 26%. If you start with 15 units, how long does it take to get to 25? We need to convert to exponential, from exponential to logarithmic, and to do that we're going to divide by 15 first. 25 divided by 15 is 5/3. On the right we get e to the 0.26t. You don't have to carry that 0. The 0 is to remind you don't lose your decimal place. Now we need to go ahead and convert. Natural log of 5/3 is equal to 0.26t. Let's verify we got that right. Natural log is base e, so e raised to the 0.26t is equal to 5/3. Yes, that's exactly what we have here. Now we need to divide by 0.26. When you do that, you get t is equal to the natural log of 5/3 divided by 0.26. That's the exact answer. If they are asking you for an approximate answer, you use your calculator and you will get about 1.96. Look to the problem to see what they're asking for. If they're asking you to round to the nearest integer, and if this was given in years, it would be about 2 years. Don't forget your little squiggly sign, that tilde, because you are approximating here. This is the exact answer. Now, if you're given a problem, this one is very similar. We're missing the rate here instead of the time, which is here they're giving us this t is equal to 7 for this particular problem. And this we're going to solve exactly like we did the last one. Now, something to note, they're asking for the rate at which this particular scenario is going to double from 10 to 20 in 7 years. What rate will that take to happen? Let's divide by that 10 again. And we divide by that coefficient so we get our exponential by itself. And then we convert to logarithmic form, divide by that coefficient, and you get the natural log of 2 divided by 7. You can then approximate that, and if they ask you to do it to the nearest tenth of a percent, we get about 0.099, which is going to give us a rate of about 9.9%. And that's the growth rate given this particular problem. Now, what happens if we're missing a different variable? For instance, for this one, we are missing the initial amount. So they're saying that, oh, negative sign, we are decaying now instead of growing. And so we are going to decay at 0.15, which is 15%. 10 years, we're going to have 15 units left. What did we start with? Now, if we're decaying, this number should be bigger than 15 because over time we have less, hence the decay and that negative here. So let's go ahead and divide by this e. I know it looks really weird, but that is just a number. 0.15 times 10, that's really 1.5. Let's just make that 1.5. That's going to give us then a naught is equal to 50, dividing this side by that, you get 15 divided by, and I flipped sheets somewhere, 15 divided by e to the negative 1.5. And you can use your calculator we get approximately 67.225, and they will tell you whether it is grams or whatever the unit is. Sorry. So that's the A naught. Now, what if they give you just a hint of the amount instead of an actual value? And so for here, we start with, again, this basic function here, A naught e to the kt is equal to your amount. Remember, the amount you have at the end, how much you start with, k is the rate, t is the time. And they're asking for how long, so we're looking for t. Let's fill in all the rest of the information. They are decaying, so this is going to be a minus sign for the rate. So the rate is going to be minus 0.0315 because we need it as a decimal. And it's half of its original amount. So half of its original amount here, the original amount is 1 unit of something, e to the negative 0.0315. And then we're trying to find t, so we leave the t there. You don't need this leading 1, but for a lot of students it helps to remind them that it's 1 unit, and then you have half of it left. And now you just go ahead and solve for the t the way we did in previous examples. Now, what if the hint that they give you is the rate? And so if they give you the rate instead, now we need to go ahead and convert this to a decimal. And it's a little weird because it has a decimal in the percentage, but the k is going to be 0.00160 from this. Move the decimal places 2 places to the left. And they're asking how long, so we're looking for t again. Now it's 1/3, so we're going to have 1/3 of the amount, whatever the unit was, e raised to the, and it's decay, negative, should have a negative here, 0.00160 t. Solve that the way you did the others in this video. Now let's look at this from a growth perspective. What if instead of decay, which was the last two, now you have growth? That means our rate here is going to be positive. They give us 1.5%, so we get k is positive 0.015. And they want to double its current population. So we don't know what its current population is, but whatever it is, we're going to double it. E to the 0.015, and again, solving for the t. Now I know we keep having a t here, but the reality is, for many of these problems, you already have other examples of missing various other pieces. This from growth and decay, we're typically looking for one of these two. While you can look for these, it's typically one of these two. So you get the idea at this point. You take this equation, the amount that you have after t time at this k rate, e is just a number, put in all the information that you have, and you're going to have just one variable left. That's always going to occur. So if you've got more than one variable, something is wrong. Then use the techniques you saw in this video to solve for that variable. Don't forget to put your answers in terms of the original problem, including those units. Hope you're having a great day.